to another math class. Today we'll be talking about binomial sorts and then conjugate sorts. What are binomial sorts? Binomial sorts are expressions of sorts in which one or both terms are sorts. In which one or both terms are sorts. For example, binomial sorts is an expression of two terms in which one or both terms are sorts. This one term is a sort here. In this other case, we have something like this. One or both terms are sorts. So these are binomial sorts. Two expressions, 6 plus root 4, root 25 plus root 3. Root 25, one expression, root 3, another expression. So binomial sorts are two expressions that are terms of expression of two terms in which one or both expressions are sorts. Now, what are conjugate sorts? Conjugate sorts are the opposite of binomial sorts. What we use to rationalize binomial sorts. For instance, we have 6 plus root 4 as a binomial sort. The conjugate of this will be 6 minus root 4. So we use this to neutralize this. So conjugate sorts are the opposite of the original sorts that we are given to rationalize the sort that we are given. Most times this ends up in difference of two squares. Difference of two squares. If you have something like we have to rationalize something like maybe something like this. The result of this will be difference of two squares. The answer of this, a plus b into bracket, a plus b in one bracket, 8 minus b in another bracket. If we are to rationalize this, eventually we are going to get this, a square minus b square. And that is difference of two squares. Difference minus here is the difference of the two squares, a square minus b square. So binomial sorts are expressions in which one or both terms are sorts, and the conjugate is the opposite we use to rationalize the binomial sorts. Let's look at some examples here. Evaluate. We have something like 2 root 3 plus 2 root 3 minus 4. 2 root 3 plus 4. This is a binomial sort. This is a binomial sort. This sort is a conjugate of this. Now, the result, the ultimate result we will get here is different of two squares. Because when we have conjugate sorts, the answer is always difference of two squares. What's the difference of two squares? If you have a plus b and then a minus b into bracket, the result will be a square minus b square. So what we will do is that we'll bring this 2 root 3 squared, and then this is the a, this is the b, this is the a, this is the b. The b is minus b will be 4 squared. So answer will be what? 2 times 2 is 4. 4 times 3. This 2 root 3 squared is 2 times is 2 root 3 times 2 root 3. That's 2 times 2, 4. 4 times 3, 12. That's 12 minus 4 times 4, 16. So the answer will give us minus 4. Let's look at the parallel here. Let's just express 2 root 3 minus 4 into bracket, open bracket, 2 root 3 plus 4. Then we multiply each by both sides. 2 root 3 into 2 root 3 plus 4. Then we use minus 4 into bracket 2 root 3 plus 4. 2 times 2, 4. 4 times 3, 12. Minus 8 root 3. Minus 4 times 2 root 3. That's 8 root 3. Minus and minus plus. Minus 4 times 4, 16. This we cut this. Eventually we have 12 minus 16. And that gives us minus 4. Here, minus 4. Here, minus 4. So when we have conjugate sorts, two sorts that are difference of 2. The result will give us difference of 2 squared. So if we just go ahead, we come this way, we get this. If we want to do the normal expansion, we get the same result. Let's look at another example here. 5 plus 3 root 2, open bracket and close bracket, 5 minus 3 root 2, open bracket and close bracket. So when we have things like this, what we'll just do is just simply say a squared minus b squared. What's a? Here, 5 squared minus, what's b squared? 3 root 2 squared. That gives us 25 minus 3 times 3, 9. 9 times 2, 18. So what do we have? We have 7 as our answer. So this, we can come this way, or we can want to expand and see whether or not we are correct. 5 minus 5 plus 3 root 2 into bracket, 5 minus 3, 5 plus 3 root 2, 5 plus 3 root 2, open bracket and close bracket, 5 minus 3 root 2. Let's multiply. 5 times 5 is 3 root 2, then minus 3 root 2 into bracket, 5 plus 3 root 2. 5 times 5 is 25. 5 times 3 root 2, that's 15 root 2. Minus 3 root 2 times 5, that's minus 15 root 2. Then minus times plus is minus. 3 times 3, 9. 9 times 2 is 18. Then this, we cut this. 15 root 2 minus 15 root 2, that's 0. So we have 25 minus 18. 25 minus 18 gives us 7. We have 7 here. We have 7 at this other side. So when we have conjugate surds multiplying themselves, it gives us difference of 2 squares. Eventually, denominator of if the denominator of an expression has a binomial surd, what we do, we rationalize. For instance, if the denominator of, let's look at something like this. If you have something like this, if the denominator of a surd is a binomial surd, we rationalize that surd by the conjugate. This denominator of this expression is a surd, is a binomial surd. We rationalize this by the conjugate. And what's the conjugate? The opposite of what we have in the original surd. A plus root b, the conjugate will be a minus root b. Let's look at some examples here. Simplify. 2 into 3 minus 3 root 5 minus 4. How do we simplify this? This is our question. So we simplify by multiplying by the conjugate. What's the conjugate? 3 root 5 plus 4. 3 root 5 plus 4. So we have 2 into 3 root 5 plus 4. And then we have 3 root 5 minus 4. 3 root 5 minus 4, 3 root 5 plus 4. So 2 times 3, 6 root 5 plus 8 over. These are conjugate surds, so we don't need to, what we just do, we just say 3 root 5 squared minus 4 squared. That will give us 6 root 5 minus 8 over 3 times 3, 9. 9 times 5 is 45. 3 times 3, 9. That's 3 root 5 squared is 3 times 3, 9. 9 times 5 is 45. Then 16 minus 16. We have 6 root 5 minus 8 all over 9. 15 minus 6, 9. Then we have 3, 27, 29. This will be the answer we will have here. So to simplify this, we have this as our final answer. Let's go again. Simplify 6 into 2 root 2 minus 1. This is so we just simplify using we simplify using the binomial. That will be 6 times 2 root 2 minus 1. We say 6 into 2 root 2 plus 1 into bracket 2 root 2 minus 1, 2 root 2 plus 1. So 6 times 2, 12. 12 root 2 plus 6 over 2 root 2 squared minus, since it is conjugate, so and we are dealing with difference of 2 squared, the expression of this will give us this a minus b squared. So we have 12 root 2 plus 6 over 2 times 2 root 2 squared is, which will give us 2 times 2 4 times 2 8 minus 1. So we have 12 root 2 plus 6 over 7. This will be our answer for this particular question here. So we don't need to be multiplying 2 root 2 times 2 root 2, 2 root 2 times 1 minus 1. No, this is conjugate sort. The result will be difference of 2 squared. So the first expression will be a, the second expression will be b. So we just say a squared minus b squared. 2 root 3 plus 2 over 2 root 3 minus 2. So this expression, they are conjugate sort. What is below the denominator is a conjugate of the numerator. So what do we do here? We just come and 2 root 3 plus 2 root 3, 2 root 3 plus 2, then we come below 2 root 3 minus 2, then we do the conjugate 2 root 3 plus 2. So what do we do? These are not conjugates because they're exactly the same. So we express 2 times 2, 4. 4 times 3, 12. This will give us 2 root 3 into bracket 2 root 3 plus 2 plus 2 into bracket 2 root 3 plus 2, close bracket. Then we'll find the difference of 2 squares of this, 2 root 3 squared minus 2 squared. So 2 root 3 times 2 root 3, 2 times 2 is 4, 4 times 3 is 12, plus 2 root 3 times 2, that's 4 root 3, plus 4 root 3, plus 4, over 2 root 3 times 2 root 3 squared, that's 2 times 2, 4, 4 times 3, 12, that's 12 minus 4. So what do we have as our answer here? We have 12 plus 4, 16. 16 root 3 root 4 plus root 4 root 3 plus 4 root 3, that's 8 root 3 over 8. We can either leave our answer this way or we find a commonality. What's the commonality? 6 plus 8 root 3 over 8. What's common to all? 8 is common to all. So we can say 8 into 2 plus root 3 over 8. 2 times 8 times 2, 16. 8 times root 3, 8 root 3. And we say 8 here 1, 8 here 1. So our answer will be 2 plus root 3, or we leave our answer this way. Say or 2 plus root 3. Either we leave our answer this way or we leave our answer this other way. simplify. 1 over 2 minus root 3. 1 over 2 minus root 3. So how do we do this? Say 1 over 2 minus root 3. Then we multiply by the conjugate of 2 minus 3. That's 2 plus root 3 over 2 plus root 3. That will give us 2 plus root 3 into 2 squared minus root 3 squared. So we have 2 plus root 3. 2 times 2 is 4. Root 3 squared is 3. That will give us 2 plus root 3 as our answer in this question. Simplify. Root 5 over root 15 minus root 10. Simplify. Root 5 over root 15 minus root 10. So how do we do this? The conjugate will be root 15 plus root 10. So we say root 5 into bracket root 15 plus root 10 over root 15 minus root 10 multiplied by root 15 plus root 10. So root 15 times 5, that's root 75, plus root 10 times 5, that's root 50, over, then we'll find the difference of two squares of this, root 15 squared minus root 10 squared. What do we have? The square root of 75 is, that would be 25 times 3 plus 25 times 2. The square root of 50 is root 25 times root 2. The square root of 75 is root 25 times 3. Then all over. Root 15 squared is 15. Root 10 squared is 10. So what do we have? We have the square root of 25 is 5. We have 5 root 3 plus 5 root 2 over 5. This will give us 5 into bracket root 3 plus root 2 over 5. Then this we call this. Our final answer becomes root 3 plus root 2. You can come this way, still say the same thing. 5 root 3 plus 5 root 2 over 5. So we collect like times 5 root 3 plus root 2 over 5. This 5 we call this 5. So our answer will be root 3 over root 2. Any of these will be the answer. Root 3 plus root 2, or we leave the answer this way. But it's simpler done this other way. Six plus root 2 over root 6 minus root 2. Let's look at this question. The numerator is the denominator. The numerator is the conjugate of the denominator, and the denominator is the conjugate of the numerator. So what do we do in this case? Say root 6 plus root 2 into open and close brackets, root 6 plus root 2, open and close brackets. Then we say root 6 minus root 2, open and close, root 6 plus root 2. So what do we do? Root 6 times root 6 is 6. Root 6 times root 2, that's root 12. Root 2 times root 6, that's root 12. Root 2 times root 2, that's 2. Over the difference of 2 squared, root 6 squared minus root 2 squared. What do we have? We have 6 plus 2, 8. 8 plus 2 root 12 over 6 minus 4. That gives us 8 plus 2 root 12 over 6 minus 2 rather, over 4. Now, we could leave our answer this way actually, but we can simplify further. Root 12. 8 plus 2, root 12 over 4. Root 12 is the same thing as saying root 4 times 3. That's 2 root 3. So we can come and simplify this and say 8 plus 2 times 2 root 3 over 4. That gives us 8 plus 4 root 3 over 4. There is a commonality. 4 is here, 4 is here, 4 is here. So we bring 4 out, how many 4 is in 8? 2. Then how many 4 is in 4? 1. Root 3 over 4. 4 here 1, 4 here 1. Our answer becomes 2 plus root 3 this other way. Thank you. Root 3 plus root 5 over root 5 minus 2. So we simplify, we rationalize with the conjugate. What do we have? Root 3 plus root 5 over root 5 minus 2 into bracket, root 5 plus 2, close bracket. Then the numerator also, we do the same thing, root 5 plus 2. Then let's open the bracket. Root 3 times root 5, that's root 15. Root 3 times 2, that's 2 root 3. Root 5 times root 5, that's 5. Root 5 times 2, that's 2 root 5. Then we do the difference of 2 squared. Root 15 squared minus 2 squared. What do we have here? We have root 15 plus 2 root 3 plus 5 plus 2 root 5 over 5 minus 3. 5 minus 4. Because the square of root 5 is 5. The square of 2 is 4. So our final answer becomes root 15 plus 2 root 3. We can bring all the root together. 2 root 5 plus 5. This becomes our answer. With today's examples that we have given, we want to believe that we've been able to get acquainted to what we mean by binomial sorts and conjugates of sort. In the next class, we'll further buttress how to rationalize or simplify conjugate sorts. Please don't forget to subscribe, like, and share for as many that this may be of help to. Meet you in the next class.